Thanks so much for the intro. I don't know that that is correct. I am lying right now. So I think let's skip past ML to get to the really important bits. How are you all doing on KubeCon Bingo? Do I need to say something, make a joke about Marsk or something to get someone to bingo? Happy to do it. I'm Dave. As Kelsey just said, he's Vish. We've been at every KubeCon ever. I feel like we're KubeCon hipsters. We were here before it was cool. But you know, thinking back to those days of the original Kubernetes and KubeCon and things like that, it's crazy to think about how many ways there were to run containers. Cron tabs, your own orchestrator, bash. I'm looking at you, OpenShift on bash. But honest to God, it was just everything was bespoke. You wrote it yourself, you ran it yourself, you had to deal with everything yourself. But a couple days ago, Alexis Richardson talked about the transformation that Kubernetes brought because it gave everyone a common platform that they could trust. They knew what the APIs are, and they could focus on the next level up. And that really transformed the entire industry that we're operating in. But Kubernetes, that's old news, 1995, who cares about that anymore? It's time for ML. ML is great. ML is the best. This is what people see when they see ML. This is Google's public information about our data centers. This is the best data center engineers in the world. These are people who spent their entire lives getting great at power usage effectiveness. These are people who are using renewable, they're using all the latest technologies. They attach ML to it, and they save 40%, hundreds of millions of dollars a year. And you know, on first blush, they didn't even know why, because no one can understand what ML model does. That's the power of ML. It is great, and it is very, very hard. And it's not just hard because I'm bad at math. It's hard because people see this ML goodness, but most folks are way, way over there. And in between, you have lots of pain. And where does the pain come from? Well, it's funny because it comes from the same place that we were with Kubernetes, 3 years ago. First, you have basically two options. One, you could do it yourself, meaning set it up from scratch. You integrate with legacy systems. You eventually get to some business need and get something working, and then you have to migrate, and then you have to change based on business need, and you have to do it all over again, and it's an incredible pain in the butt. Or you could go with hosted, and hosted is great for 5 minutes. And then the next 5 years of your life you spend doing everything you did before. You have to take it apart, you have to figure out how to integrate with your legacy systems, and by the way, you're locked in, so you can't even migrate to do what you need to do. And I should say, this is not all hosted solutions. There are some that are doing some great things out there, but certainly this is the way a lot of things are going. So, like I said, haven't we heard this story before? We did. We heard this around containers and Kubernetes. And specifically, I'd like to call back to the last KubeCon keynote, where Ken Goldberg talked about all the extension points that Kubernetes provides, meaning you don't have to make changes to the core to take advantage of all this great goodness. You're able to reliably use the Kubernetes native API and go up from that. And what that enabled were cloud native apps. These were apps that had a common understanding of what was available under the hood, and it meant that you could focus on the things that really changed your business. So, we need cloud-native ML. And cloud-native ML would do this exact thing. We think of cloud-native ML as really adopting the following three components: composability, portability, and scalability. By composable, I mean today you build a model. And this is where everyone focuses their time. But this is not where data scientists focus their time. They end up focusing their time on everything built around this. A whole set of microservices loosely coupled together that together comprise what is really an ML solution. All the way from that initial thought, bringing your data in, splitting it, training it, productionizing it, and then rolling it out to production. That's what an ML solution looks like. It does not look like just building a model. And worse, every single data scientist is going to have a slightly different view on what the right tools are and how to actually roll these things out. And that means you need a highly composable solution, one where every data scientist can choose the components that are meaningful for them. Second, you want it to be portable. I already talked about the fact that every data scientist and every solution is going to be slightly different, and this is what a stack looks like. And I'm probably leaving off 100 other boxes here. The entire stack that I talked about earlier, that fits into just that top part. That sets aside everything below, runtimes, OSs, drivers, and so on. And the worst is once you get everything finally up and running here, you then have to replicate it again when you get to training, and then you have to replicate it again when you get to cloud. So again, you need a portable solution that you can move across these various things. And finally, I mentioned scalability. A lot of people think about scalability, just more nodes. In ML, certainly more nodes help, but you also have to think about all these other elements. Accelerators, CPUs, disk, and then how about some non-hardware things of scale? How about skill sets? Is this an intern, a data scientist, a SWE, a researcher? How about teams? Are they geo-distributed? How about just more experiments, running them over and over again simultaneously? So composability, portability, and scalability. And you know what's really good at composability, portability, and scalability? Containers and Kubernetes. Except, if you want to use ML on Kubernetes, you have to become an expert in a lot of things. The problem is that data scientists are really, really good at doing data science, but they don't have SWE or IT ops in their name. They really want to focus on what they do well. And that's why we introduced Kubeflow. We want to make it easy for everyone to develop, deploy, and manage portable distributed ML on Kubernetes. We introduced it at the last KubeCon, and we have been so overwhelmed with the people who are contributing to it. The idea behind Kubeflow is to try and address all three of those components simultaneously: composability, scalability, and portability. We leverage the fact that Kubernetes exists everywhere. It operates in all these environments, from your laptop to your training to your cloud. You create your configuration out of Kubeflow, and then you roll it out in each location. And all you have to do is change your parameters in order to adapt. And we are very proud today to announce Kubeflow 0.1, or if you're from the Southern Hemisphere, 1.0. In the box today, we have all the components for an instant-on ML solution. Did I mention it's 0.1? Please don't use it in production yet. We are very, very excited about it, but it is right at the beginning, and still you are able to get very productive models built already. You have Jupyter, you have distributed training, you have model serving, and best of all, you have packaging to let you customize it yourself without making changes to the underlying APIs, without doing a bunch of different package installs from different operating systems and distributions. And with that, I'd like to hand it off to Vish to show a demo of what this might look like.
So the goal here is to show the operational efficiency that you're going to get with Kubeflow, Kubernetes, and also the ease of use, the scalability, and other aspects of ML. So it's not about building a model, but more about showing what it takes to build a model and serve it in production. So what I got here to demonstrate that is a very simple review app. So let's say you're having a restaurant, and then you want to highlight the positive reviews that you have automatically in your website. So I go and ask my engineer to do that. What do they do first? They build a very simple naive model, and the naive model is as simple as, oh, I know these words don't match, like they're negative, and there's these other words that are positive. I mean, I guess it works a bit, but it's not really good code, right? So how can I improve this? Let's use machine learning. There happens to be really good NLP models, and tensor to tensor happens to be one that you can use, and it's like really pre-packaged well. So all you got to do is like retrain it for your specific use case. In this specific use case, it's going to be, how do I get reviews to be digested and build models out of it? So let's go ahead and do that. What I'm going to do first is I'm going to start I can't type and speak, so I have everything scripted here. I'm going to first start training locally. So I'm here switching to my local Minikube cluster. And the general idea here is that you can iterate really quickly locally on your workstation or on your laptop. Then once you feel comfortable with your model, then you can take it to the cloud. So let's first get going with the local environment. So this is all I did for literally installing Kubeflow. So what you get is you get all the components that David mentioned, but they are prepackaged in a way that it's Kubernetes native, and it's really easy to use. So you don't have to go and create a whole bunch of objects to make it work in Kubernetes. So once Kubeflow is installed, I want to show you how Jupyter works here, for example. So Jupyter is already prepackaged, so you can have notebooks locally or in the cloud. And since you get Jupyter Hub, you can choose from a variety of pre-canned images, and you can change the resource limits. This is like the most common API that most people care about. And then once you hit spawn, you can actually have a notebook. But for today, we're not going to use notebooks, but we're rather going to use the command line. Because I assume we're all fans of kubectl, right? So I'm going to switch to the command line. So what I did here is I configured my model that's packaged through KSinit. I configured it to run locally. So I set it to, I've set the PVC name, so I set up a PVC locally so that I can use the data that is available locally on my laptop to train, rather than pulling it somewhere from cloud. And I also set the local training to be true. Right? I did that, and then I went ahead and deployed the model locally. So the model is now running, and I'm going to show you that the training pods are running. So what happened behind the scenes is, with KSinit packaging, you're able to convert a few user-level primitives and then translate them into Kubernetes declarative configurations, and have it applied to your local Minikube cluster. And there's a TensorFlow operator that's running as part of Kubeflow. And what it did was it translated those higher-level user requirements and then converted it into actual Kubernetes pods, which is what you're seeing here. And it translated it in such a way that TensorFlow has its own concept of clusters. So it translates the user higher-level specification into a TensorFlow configuration behind the scenes. And just to show that training is actually running on the local host, I guess, well, that's live demo. So Minikube is not happy about it. But that's not the point of this demo. The point of this demo is to show that it's possible to run it locally and also move it to the cloud. And so I'm going to show you that now we're going to switch to a Google Kubernetes Engine cluster. I'm going to show you the cluster that I'm using here. I have a cluster that's pre-provisioned because we want the demo to run through quickly. So the cluster is pre-provisioned, and you have GPUs in the cluster. And you have a whole bunch of nodes that have GPUs pre-provisioned. And there's also TPUs attached to this cluster. And you can use TPUs from any of the nodes. Pre-provisioned a TPU for this demo. I'm going to go back, and I also deployed Kubeflow to the same cluster. I'm going to change the configuration to make it work in the cloud. So I have to update a few parameters. I have to update that the data is going to be stored on Google Cloud Storage. I'm also going to say that my output, the model checkpoints, have to be stored on Google Cloud Storage because you have many different pods, multiple writers, and Cloud Storage happens to be the best interface for multiple writers. And once I did that, I went ahead and deployed the model. And then now I'm also going to deploy a model that's using TPUs. So I'm going to configure my TPU model and then go ahead and deploy that against the same GKE cluster. So now that's done, we're going to wait for the pods to run. And you could use the GKE UI here to figure out whether the pods that we deployed are running. So you see here that there's a TPU pod that's running, that's running the TPU training model. So we can go in here and probe the logs to check that the model is actually running. So you see here that model training has actually started. And if you go back and if you look at the GPU model, you'll see the same, that training is actually starting and it's running in the cloud. So you probably have to wait for a bit for training to complete because it's going to take almost an hour for the model to be fully trained. But we don't have that time here. So what we're going to do instead is we're going to use a prepackaged model. But before that, I also wanted to show you that you get TensorBoard integration out of box. So if you're not familiar with TensorBoard, it's a really useful UI that gives you insights into how your training is actually progressing. So with TensorBoard prepackaged, so once you go through the training, what you're going to see is you're going to see graphs like this where it show you the training rate. Like for example, here the training rate with GPUs is about 2.5, whereas like if you switch to say TPUs, the training rate is going to be like much higher for this specific model. So you get some speed boost there. So this is to show that like you get all the tools sort of prepackaged and it's ready to go as soon as you start consuming Kubeflow with Kubernetes. So training is going to take some time. We can't wait here. We still have our sample web app, the restaurant app that needs to be optimized. So I'm going to use a pre-built model, and I've deployed that model to the same GKE cluster. So let's just go check that the model is actually running. So you see here that there's a deployment here which is actually serving that model, and the deployment is now running. So I'm going to go back to my review app, right? And earlier what we saw is, we saw this first review here. As a human, we know that it's not really a positive review, but then our naive classification classified it as a positive review. Let's see if the machine learning model does any better. OK, there you go. So it was able to generalize, and it was able to figure out that there's more context associated with language, and it was able to perceive that it's actually a negative sentiment and not a positive sentiment. So this is to show that you have lots of great tools, and like David said, it's like 0.1. So there will be things that you have to fix here and there, but then you get something that gets you going, and we're able to like show that you can go through the whole journey within like 4 or 5 minutes now. And so you should be expecting the same when you get this going. And I hope that everyone gives it a try and feels empowered to do ML. With that, like, David?
So, as someone who's loved ML for years, I was absolutely blown away when I saw that for the first time. The amount of configurations and changes and installation you have to have something run locally and then run in one environment and then run in a second environment attached to 2 different accelerators today is crazy. And you saw it happen on stage. That was a real live demo of it actually running in all these various locations and experimenting in a way that massively increased the performance. What you didn't see was bespoke solutions. Every one of those packages we were using encapsulate an open source ML solution today that with large communities that are fully production ready, and we are really, really excited to help those communities come and use Kubeflow as a way to get their solutions out to the market. Second, you didn't see any cloud-specific tech. Even the elements of running on GCP, attaching to GPUs, attaching to TPUs, deploying node pools, those were abstracted away. We used the exact same deployment from Kubeflow on-prem as we did on the cloud. The only thing we did was change some parameters, which is appropriate, because you want to point it at the place where it is. We didn't have to change any code or other configurations. And you also didn't see forking of the Kubernetes APIs. We used the natural extension points to create TensorFlow CRDs that include master servers, parameter servers, and worker nodes. A very complicated deployment that understands how to communicate with each other. We did that natively. And that's really where we are today. We want to enable this brand new world. In this case, we are talking about data science. And data science will impact every industry. But we can't ask everyone to become experts in everything. We need to use, just like Kubernetes does, natural extension points to give people the power to make changes. And I love this story. There was this town in Sweden that was seeing a higher incidence than they would like of injuries after new snowfalls. And they used data science to watch and see that it happened to be women and stay-at-home parents who were the ones who were seeing the majority of these injuries after snowfall. By doing a bunch of data science, measuring all the ways that people were getting injured and where it was coming, what time of day, they realized they had just misprioritized. They were plowing the streets first instead of the sidewalks, and the sidewalks happened to be where the women and stay-at-home parents were the ones who walked in the morning. And so by doing nothing else but shifting the order of how they plowed their streets, they were able to save lives, reduce injury, and improve people's lives. But those data scientists, those people operating at that level, the public policy people, the snowplow scheduling people, they were not going to understand Kubernetes APIs, anything under the hood. We need to give everyone the power to use the tools that we are building. And we need to do that by providing clean extension points and clear ways to build on top of the tools that we're building. Now, we're just getting started. We have over 70 different contributors to the platform right now. We have 17 different companies you can see here who are contributing. You have great use cases. OpenFaz released a really cool serverless solution for colorized.bot against Kubeflow, and we're really excited. And we have a whole bunch coming next. 0.2 is coming very shortly, we hope this summer, with significantly easier setup, better abstraction around some key Kubernetes features, auto-scaling accelerators. Lots more packages. I mentioned TensorFlow a lot, but we already have PyTorch in. We have a Cafe proposal. And we really do want every single ML tool to be deployable via Kubeflow. And my dream really is that in, call it, a few years' time, every single research paper in the world has 3 things associated with the end of it. First, a Kubeflow deployment. Second, a model. And third, a package of data. And with those 3 things, we can make genuine changes and improvements around the reproducibility problem. But most of all, Kubeflow is open. We are listening. We want to solve real problems today. You tell us how. We are open in all the ways it is possible to be open: GitHub, Slack, Twitter, you name it. But we would love more than anything to empower all of you to take this and make Kubernetes the platform of choice for ML in the future. Thank you very much.
Thank you.